As we already know that the VLSI technology, as it stands for very large scale integration, and this is a course which is in your fifth semester. Okay, and as I told you in the last lecture that it is most of the theoretical kind of subject, how nowadays ICs are manufactured. Okay, then this ICs will be used for manufacturing the other electronic gadgets. So first of all, as I told you about this particular syllabus, okay, that the syllabus is there for you. So these are the content of your syllabus. Okay, VLSI technology. In the unit 1 you have to go through the introduction part, introduction to IC technology, and then we have to go for the epitaxy, oxidation, lithography, dielectric. These are the different processes that we have to go through. Okay, that we have to look at. Okay, so I'll be going one by one. Before that, I will be giving you a small introduction about this subject so that you will be able to understand uh, what is this subject is all about. Okay, that is more important. Fine. So why we are studying this subject is more important. So first I'll try to explain you. And before that, I told you that about the books that we can follow for this particular subject. So you can see here, we can follow the textbook like SMZ, VLSI Technology by McGraw-Hill publication. Okay, this book we can follow, right? Then we can also have this JD Plummer book. So I told you last time that the JD Plummer book is a very important book in this VLSI technology context, because any other books if you find, it will be giving you information, but more detailed information you will find in the JD Plummer's book. Okay, so this JD Plummer's book is more important, right? So if anybody want to study, you will get the full detail of everything, right? Most of the details you will find in this particular book, JD Plummer. So you can go through this JD Plummer book. It will be very helpful for you all. And because we are studying it the first time, okay, so you try to go through it. You have a lot of time, so you can build up your concepts. Okay, so that you try to do. So apart from these two books like SMZ, VLSI Technology, JD Plummer, we can also follow another books that I will be following. Okay, most of the time I will be following this JD Plummer book. Okay, so I will be most of the time I will be following this JD Plummer. So what you can do is, uh, you can follow JD Plummer. You can also follow SMG VLSI Technology books, and sometimes I will be following these two books also. Right, these two books I can be following, like Basic VLSI Technology, Basic VLSI designed by Douglas A. Bucknell, and the CMOS VLSI designed by Neil H. E. Weste. So these two books I will be following sometimes. Some of the contents have been taken from these two books also. So first of all, we have to understand what is this VLSI technology. Like I told you, the full form of this VLSI is very large scale integration technology. Okay. So what is this very large scale integration? Okay. Why we are going for integrating something, and why it is called as very large scale integration? Okay. So before starting the subject, we need to go through some of the historical background, how the technology has been evolved for the last, you can say 100 years or more than 100 years now. So first of all, you know that the semiconductor devices, actually it was known to us for a large, means for a very long time, but still the devices that we are using nowadays, actually it is come up in the middle of your 20th century. Okay, so before this semiconductor devices, we are having the vacuum tube devices, right? So you can see earlier days we are having these type of devices, which is called as the vacuum tube devices, and they were, most of the devices were electrical. They're not the electronics, okay? They were electrical in nature. And you can see we are having the Fleming's first diode that was looking like something like this. Then we are having a triodes. Okay, so these are the different triodes I have taken here, just to show you how this triode is actually evolved over the years. So it is from 1918 to 1960. You can find a different type of triodes evolution have been taken place, and we are getting a different type of triodes. Okay. So what is the important thing that we need to see in this particular slide is, you can see the Fleming's faster diode that we can see here. It is having a very large shape and size. Okay. And at the same time, you can see also the triode is, it is also having a very large shape and size. It is not a small elements like we are having elements like today's time. Okay, like diode, transistors, whatever we have, those elements are actually occupying a very less space. But if you see in this particular case, these are the vacuum tube devices, and they were actually occupying a very large space. So basically, if you see, if you think about these devices, right, then obviously if we want to fabricate anything out of these devices, okay, then obviously if you make a connection of these devices, it will be performing the same function that our today's semiconductor electronic devices, whatever they are performing. Like we are going for diode, we are going for transistors, so they are doing amplification, they are doing switching applications, they are doing some other applications, like we can use it as a resistors, we can use it as a voltage control current devices, current control voltage devices, like that. Okay, so you can see that if these functions has to be performed by these vacuum tube devices, then we have to make a particular connections, and obviously because the size is very big, so if we have to make a certain circuit or any particular device, it will also occupy a very large space. So this was the problem. Okay, and you can understand by this picture that we are having this particular vacuum tube devices in the very beginning of your 20th century. So somewhere in around 1904 or 1905, these vacuum tube devices were invented. Okay, and then it was start evolving, and we got a number of different vacuum tube devices. Now what we can see, based on these vacuum tube devices, we could have made a particular computer. Okay, so if you heard about the ENIAC, okay, so this is one of the picture I have it's included in this particular slide, just to show you that this is one of the first computer which is called as ENIAC. So ENIAC stands for your electronic numerical integrator and computer. Okay, so this is our first electronic general purpose digital computer. So this is one of the picture of your first electronic general purpose digital computer, in which we could write any particular code, and that code can perform a particular task. So you can see this particular ENIAC computer was actually introduced in year 1946, and it was actually occupying a very large space. Okay, so you can see it is just like a building. It was a big building. Okay, we having a very big building, and in that big building, we have to place, or we have to make a entire computer, and then we have to take care of everything, like all the devices are functioning properly, and then we have to keep on taking the readings. Okay, then you can see there are certain employees are standing over there, they are noting down some readings. Okay, so you can imagine because of the vacuum tube devices or some other electrical devices which is actually occupying a very large space, we had a very large size of computer that time, which was introduced in somewhere around in the 1946. So why it was occupying a very large space? Because the elementary the elements that we were using for manufacturing these devices, these computers, was actually occupying a very large space, like vacuum tube devices or any other electrical equipment. They were occupying a very large space, and that's why whenever we were assembling these devices to perform any particular function, it was also occupying a very large space. So that's why you can see the computer in the earlier times, it was occupying very large space. Now if you compare from this to this, okay, you just see these are the electronic components that we are having in the electronic time, in the modern times. Okay, so we are having a large such electronic components. The basic components that you might have come across is diode, transistors, MOSFETs. Okay, These are the basic electronic elements. Okay, CMOS, MOSFETs. Okay, these are the basic elements. Now you can see just this particular picture is kept here to just explain you how small these devices nowadays are. You can see we are having a large means we are having a LED, we are having transistors. Okay, we are having transistors. So these transistors are actually occupying a very small space. Okay, very small space as compared to your vacuum tube devices, which is very important to understand. Okay, and then we have to think of how it is possible, right? How it is possible uh, that we have earlier vacuum tube devices, and now we are having some electronic devices, which is occupying a very small space. So if we are having a very small space occupied by this elementary component, then if anything that we will be making using this particular elementary component, then obviously that devices will also be occupying a very small space, which is very important to understand. So now what we can think of, these are the devices which are occupying very small space, and how it was invented, when it was invented. And because these are the semiconductor devices, okay, these are the semiconductor devices, solid state devices. Okay, we have to study about these devices. Okay, how these devices are actually manufactured. Okay, and what are the different processes that we have to go through, what material we have to choose. Okay, that all questions, that all queries we have to answer. Okay, and this is not the only size. You can see these are the basically elements that we come across, we generally see in our laboratories. Okay, the laboratories you may find that we are having a transistor of this particular size, but you can see this size is also very big. If you compare from your ICs, we are nowadays we are having certain integrated circuits. In that circuits, this much of space is very large. Okay, this particular size that we are showing up here, this size is also very large. Within this size, we can incorporate a very large amount of transistors, right? So how that is possible? If possible कैसे हो रहा है, that we have to look at. Okay, how we can incorporate means so many transistors within a very small space. Okay, so that we have to look at, and that this VLSI technology is all about. Okay, we have to study about very large scale integration, how we are integrating this particular means small elements like transistors. Okay, into a very small space. Okay, that we have to look at, that we have to study. So if you are having any doubt, you can write your problems in the chat box. Otherwise, we can continue. Okay. So in between, students are keep on joining. Okay, it is making a lots of noise. Okay, fine. So from this particular electronic component, whose size is already very small, you can see. If you think about, okay, if we think about what kind of electronic gadgets that we can make. So you can think about nowadays we are having this type of electronic gadgets. Okay, so you just compare from the ENIAC. Okay, that the slide I have shown to you, which was introduced in the 1946. 1946. So that devices was that computer was occupying a very large space. But as compared to that, if you see this particular electronic gadgets, you can see we are having ultra thin laptops, we are having desktops, we are having printers, we are having pen drives, we are having some memory chips. Okay, we are having smartphones, lots of such devices which are very much handy and portable. Okay, it is occupying very small space, and yet its performance is much better than what we have got in the 1946. So obviously, if you compare, okay, if we compare from our first computer, first digital computer that we have made, like ENIAC, if you see the today's electronic devices are occupying much lesser space, and its performance is much better than what we had that time. So basically, what we can understand from this is when we are reducing the size of our electronic components, not only its size is going to reduce, but its performance is also getting improved. Okay, so that is the beauty of this particular technology, that we have to understand how it is done and how we are manufacturing such a devices which can be able to means embed lots of electronic component into a small space. Okay, so just for an example, I just want to show you about this particular microprocessor. So you just uh, think about this particular microprocessor. This is your Intel Centennium microprocessor, and this microprocessor was actually launched in somewhere around in year 2008. And you will be wondered to know that this particular device, this particular microprocessor, is containing more than 2 billion transistors. Just to try to imagine. So it is having a small size, and yet it is containing more than 2 billion transistors. So that is a very wonderful thing that we have today. So how this technology is evolved, that we have to understand how it is possible to embed or integrate 2 billion transistors within a particular microprocessor. So this number is drastically improving. Okay, it is not like that. It is just 2 billion transistor. Nowadays we are having a lots of transistors. It keep on increasing. Okay, year by year. So it is keep on increasing, and we can integrate more and more transistors into a given chip, right? So I'll be just going through a brief history of semiconductor devices, okay, uh, that we have already invented, and their invention took place right from 1874. Okay, so it was started in somewhere in the 1874, and that time a particular inventor was your Braun, who have invented the metal semiconductor contact. Then 1907 we have light emitting diodes. Then the major breakthrough that we have got in the semiconductor industry is the invention of your bipolar transistor. Okay, so you can go through this all inventions, but basically the most important thing that we have today, that we have to study for our VLSI technology or for ICs, means which is important in the point of view of IC fabrication, is your bipolar junction transistor. Okay, bipolar transistor. So you can see this bipolar transistor was actually invented somewhere in around 1947. Okay, so 1947 bipolar transistor was invented, and this was actually invented by these three scientists, Bardeen, Breton, and Shockley. Okay, so if you go through the details of this, you will find that Bardeen, Breton was some of the research scholar, I hope, and they were working under the William Shockley. Okay, William Shockley was the professor, and they were working under him, and they actually invented this device, bipolar junction transistor. Okay, then they wrote a very excellent paper. The Stokely have written one excellent paper about their invention. So we have invented a particular solid state devices, which is a three-terminal device in which the amplification was observed. Okay, so this is the major breakthrough that we have got in our history of semiconductor devices. Okay, so bipolar junction transistor. So we have to actually focus on these basically these two devices. First is your bipolar junction transistor that was invented in 1947. Then we have to think about when this ICs was actually invented. Okay, so here I have not written when the IC was invented, but I will tell you in the next slide. And IC was also invented in somewhere around 1958 and 59. Okay, you will get this year in the different books. You will find this year is written somewhere as a 1958. Somewhere you will may find 1959, 1960. Okay, so don't bother about the year. Okay, you can follow any of the book. Okay, whatever book you are following, whatever year they have written, either it is 58, 59, or 60, you can follow them. Okay, so we have to look at these particular uh, uh, mm, these particular devices, right? 1947 bipolar junction transistor, and then IC that was invented. And the another device which is very important is our MOSFET. Okay, the invention of the MOSFET. Okay, so basically the base of any IC is your MOSFET device, right? So you can look at these devices. The MOSFET was somewhere in 1960 it was invented, and it was invented by this Kahan and Atala. These are the two scientists who invented this particular device, MOSFET. Okay, so if you go through the history of your invention of this different semiconductor devices, what you will find is uh, this MOSFET was not actually it is invented in the 1960. Okay, this is the functional MOSFET that was invented. So the first idea came in somewhere around in 1935 about the MOSFET. Okay, but that time the scientists were unable to show the functional devices. Okay, they were not able to make a functional MOSFET. Okay, but the idea was there in 1935. Okay, but it was not means shown successfully. They might have a certain material defect, and that's why they were not able to show the function of the MOSFET. Right? So we have to look at how this bipolar junction transistor invented, and then we have to look at how the ICs was invented. Okay, and then we have to look at about the MOSFETs. Why the MOSFET is very important, that I will tell you in the next slides. So you just try to see the invention of the transistor, okay, and integrated circuits. So this is one of the picture that you can see. Okay, this is our first transistor. Okay, this is our first transistor that was built by the Walter Brittain, Barding, and William Shockley. Okay, so this is the first picture of that particular device. So this was actually built in 1947 at Bell Labs. Okay, so Bell Laboratory में इसका first manufacturing हुआ था, इसका invention हुआ था. Okay, so they manufactured, they built on particular polycrystalline germanium. Okay, so this is important information that you have to note down, that this particular transistor that was built in year 1947 at Bell Labs by these particular three scientists. Okay, this device was actually built on polycrystalline germanium. Okay, right now you may be not able to understand what is polycrystalline. I will tell you what is polycrystalline. Okay, but you know that germanium is a semiconductor device. So we already know that the silicon and the germanium is the basic semiconductor elements. Okay, these are the elemental semiconductors. So when they made it first, it was made on the polycrystalline germanium, right? This is our first transistor. Okay, so they have made it in somewhere around in the 1947, and they got for this device because this device replaced the all other vacuum tube devices. Okay, that's why it is called as a major breakthrough in our semiconductor industry. Okay, so in the semiconductor industry, we got a major breakthrough in somewhere in the 1947 due to the invention of the transistor. So you can see this was built on polycrystalline germanium, and it is also called as point contact diode. You'll find that in the books. You'll find that it is also called as the point contact diode. And for their invention, okay, they received Nobel Prize. These people got the Nobel Prize in year 1956. You can understand someone is getting Nobel Prize for their invention, then how important that invention may be. Okay, so they received a Nobel Prize in somewhere around in 1956. Then you can look at the another device, which is our first integrated circuit. Okay, you can see this particular device is your first integrated circuit. Okay, so what they have made is they have tried to make a flip-flop, okay, flip-flop circuit, okay, that was built on a same germanium slice. Okay, so you can see this was actually made by a scientist whose name was Jack Kilby. Okay, so Jack Kilby is the scientist who made the first IC, and he made it in made it at Texas Instrument, and somewhere around in the 1958. So I told you, you do not bother about this particular year. You may find that in some books it is written as 1958, somewhere you will get 59 or 60. So I'm just considering it as 1958, somewhere around 1958. They have built this particular first IC, and that IC was actually constructed from germanium slice and a gold wire. Okay, so on a germanium slice, they have made this particular IC that was your flip flop. And for their invention, again, Jack Kilby received the Nobel Prize in year 2000. Okay, so after a very it's a long time, he received his Nobel Prize in year of 2000. Okay, we will realize that the invention of IC was actually a major breakthrough for our electronic industry. So basically, these two devices, right? One is your transistor, and another one is your IC. Okay, so these two devices are actually a major breakthrough. If you see, one more important point that I want to point out here is, if you remember this Jack Kilby, okay. So if you see, his name is Jack Kilby. If you see this particular IC is a flip flop, okay. So you try to note one thing, that if you have studied about the digital circuits and digital electronics, you might have studied a different type of flip flop. So you study about one of the flip flop which is called as the JK flip flop. Okay. So JK flip flop, J stands for Jack and K is for the Kilby. Okay. So that JK meaning is Jack Kilby. It is the name. It is the name of Jack Kilby. It is that pen given the name. Okay. So he is not the only person. Okay, Jack Kilby is not the only person who was actually working on making a IC. Okay, at the same time, one more scientist whose name is called as uh, Robert Noyce. Okay, I have not written the detail of that particular scientist, but one of the person whose name was Robert Noyce. Okay, so Robert Noyce was also working on means making a IC. Okay, he was also trying to manufacture a IC, and he was also successfully built the IC. But the work of Jack Kilby was first, I think, he recognized, and that's why all the credits are actually goes to Jack Kilby. And if you know about the Robert Noyce is the scientist who is the co-founder of your Intel's company. If you know the Intels, okay. So one of the semiconductor giant, you know that Intels, we are having a lots of devices and Intels microprocessor we have. So the Robert Noyce is the co-founder of your Intel's company, okay. That was I think established somewhere around in the 1966 or 67. Okay, so Robert Noyce was one of the important person, right? Then you can also try to find it out who is the other co-founder of the Intel. So you just try to Google it. You will find the name of the other person who have uh, yeah, co-founder of Intels. Okay, so one person is the Robert Noyce, and another one is one more person. You can try to Google it. So this is the two devices which is very important. Okay, like transistor. We are not going into the details. Okay, means how these devices was actually made and how it works. Okay, what are these particular uh, triangular shape element? Okay, so I'm not going into the detail. It is not required at this moment. Okay, so I just want to give you certain information about the history, how it is invented. Okay, so that's why I'm just giving you the historical point of view, so that you try to first understand what are the devices which have come up, and what is the importance of those devices that we have to understand. So this is another picture of your IC and your transistor. This is the transistor that is actually kept in one of the uh, place, okay, just for showing the people. Okay, so this is your point contact diode, or the first transistor. It is just a prototype of that to show the publics, okay, for demonstration purpose. And this is how nowadays our IC looks like. Okay, we are having a large number of pins. Okay, we are having certain internal circuitry, and that circuitry will be known to the manufacturer. Okay, and they will provide a manual that we can means that will tell you what is the meaning of the different pins and how the pins should be connected to the outside world to get a particular function. Okay, so if we want to get a particular function, we have to know its internal circuitry. Now, one more important device, okay, that we have to study about is the invention of MOSFET. Okay, so this is very important device when we talk about our IC technology. Okay, so for IC point of view, this devices is very important, right? I will tell you why it is very important, but first of all, try to understand. As I told you, you might have seen in the table. Okay, in that table, I shown you that the MOSFET was invented in somewhere around in 1960, and it was invented by the Kahang and Nattala. Okay, the two scientists. Okay, who invented this particular device. So this is the first MOSFET. Okay, so you can get a certain means information about these devices. So what are the information about these devices? You can see we are having the. I think you must have studied about the MOSFET because you are now in the third year. So MOSFET का structure कैसा होता है? You already know it. Okay, like in the MOSFET, what we are having a gate, we are having source and drain, and in between we are having channel. Okay, that will be built on a particular substrate. Okay, then we have to make a source connection, we have to make a drain connection, then there will be an aluminum gate or it could be a polysilicon gate. Nowadays we are having polysilicon gate. Okay, then there will be a oxide layer. Okay, and then we have to make a connection. Okay, so that are the different terminals, like we are having a body terminal, source, drain, and gate terminals. These are the different terminals that we have. So this is the picture of your first MOSFET that was built on somewhere in the 1960. And now you can see some of the important parameters of this particular device. Okay. So what are the parameters that we have to see is you can see the gate length. Okay. Uh, this particular device, when it was built in somewhere in the 1960, it is having a gate length. Basically, it is gate length, or you can say it is a channel length. Okay, that is the distance between your source and drain, and which is also called as the feature size of your devices. Okay, so you try to remember this terminology so that when we discuss about the feature side, you will be able to understand what we mean by feature size or gate length. Okay. So basically, gate length is your width of your uh, gate layer that we are means laying on onto your oxide layer. Okay, so it is the distance between your source and drain. Okay, so whatever be the channel length we have, the same length we have for the gate also. Okay, and that gate is called as the feature size. Okay, and when it was built in 1960, this gate length was somewhere around 20 micrometer. Okay, to try to understand, it was having a channel length, or it was having a gate length, or having its feature size, which is of 20 micrometer, and it is having an oxide thickness of 100 nanometer. Okay, so its oxide thickness was somewhere around 100 nanometer, and it was made on silicon substrate with aluminum gate. So this was the some of the information about your MOSFET that was built in 1960. Okay. What are the main point that we have to understand about this? First of all, this device was made on silicon substrate by following the aluminum gate process. Okay. And then it's having the feature size, or the gate length was around 20 micrometer. And then the oxide thickness was 100 nanometer. Okay. So these are the some of the features of this particular MOSFET that was built in 1960. Now, one important point that we have to look at is basically when we are manufacturing any IC. Okay, whenever we are going for making an IC, what are the basic elements that one can have within an IC? Okay, so either the basic element for making any IC, it can be a bipolar junction transistor, or it can be a MOSFET. Okay, metal oxide semiconductor field effect transistors. So basically, we have to think of whether we have to go for BJT or whether we have to go for the MOSFET. Okay, so that we have to look at. So which particular device we have to choose, which particular element we have to choose. Okay, so I hope today's time is 9:40. 9:50 is already there, so you must have next class, I hope. Okay, so we will be continuing your class in the next tomorrow's class. Okay, I will continue from this particular slide. So you just wait for some time. Okay, I will take your attendance and then you can leave the session.